The picture shows an electrical bicycle that is usually powered by making a combination of riding and pedalling an electric motor. Right, a 36-volt battery powers the electric motor. The battery is made of individual 1.2 volt cells. Explain how a 36-volt battery can be produced using 1.2-volt batteries. To gain marks, you must include a calculation in your answer. So what we're looking at here is we've got to think back to what we were talking about in series in the last question. In series, okay, not only is it that the resistance total is the sum of them all added together, okay, which we've already talked about, it's also true for voltage. So the total voltage is equal to all the voltages added together. So in that case, if we have 36 volts as our total voltage, and we know that each unit is going to be 1.2, we need to know how many of these 1.2s that we've got. So that's going to be 36 divided by 1.2, which is going to give us a total of 30 cells. A battery supplies a direct current. What does that mean? A direct current means that the current flows in one direction only. When fully charged, the battery can deliver a current of 5 amps for 2 hours. Then the battery is fully discharged. Calculate the maximum battery, the charge that the battery stores. So we're back to our equation, Q equals IT, that we have been looking at in lessons. So we're looking to find the charge. We've got the current, substitute that in. We've got 2 hours now. Hours. We need to turn hours into seconds. Okay. Now, to remind you, we've got 60 seconds in a minute and 60 minutes in an hour. So we could do times by 60 times by 60 twice, or we can times by 3,600 that we looked at doing as well. So if we times by 5 by 3,600, okay, we'll get an answer. Oh, sorry, no, that's 1 hour. It's 2 hours, so it's 7,200. 3,600 seconds in 1 hour, so 7,200. So if we times 5 by 7,200, we get 36,000. And then we need the units on our answer, which is coulombs, big C, or coulombs. Okay. Part B. When powered only by the electric motor, the bike can carry a 90 kilogram rider at a maximum speed of 6 meters per second. Under these conditions, the maximum distance the bicycle can go before the battery needs to recharging is 32 kilometers. The bicycle has a mass of 30 kilograms. Calculate the maximum kinetic energy of the bike and rider when the rider is not pedaling. So we're looking at the equation EK for kinetic energy is equal to half mv squared. So when we've got all that information, we need to substitute in the values that we've got. So the m is for the mass. Now the mass is going to be 90 plus 30, which is 120. So half times 120. We've got a velocity or speed of 6 meters per second, so that becomes 6 squared. And if you pop that into your calculator, you should get a total of 2,160 joules. The bicycle can be fitted with panniers, bags to carry a small amount of luggage. What effect would fitting panniers and carrying luggage have on the distance the bikes can cover before the battery needs recharging? Well, it's going to cause the mass to increase, isn't it, if we're adding more mass. So if we have more mass, it's going to reduce the distance before recharge. Give reasons for your answer. We're going to draw a larger current, so I'll just put some reasons here. Draw a larger current. If we're drawing a larger current, it's because the motor needs more power, because more mass. Or another reason that you could talk about is that there is greater resistance, air resistance and drag to do that. So greater drag, therefore more power needed. Just saying mass increase is not going to be enough to get any marks for that question.